So let's start solving a few questions, good question from electrostatics and gravitation. So the question number one, there is a particle, mainly the PIQs, there is a particle moving having charge Q and mass M under an electric field E equal to E naught 1 minus AX square in the x direction, where A and E naught are the constant. Initially the particle is at origin at x is equal to 0. Other than the initial position, the kinetic energy of the particle becomes 0 when the distance of the particle from the origin. So at some position again the velocity will be 0, because initially the electric field will, whenever x is very small, electric field will act in this direction because E is positive 1 minus ax square. But after some time, whenever this x becomes getting a higher value, then this electric field become negative, so electric field will act in the opposite direction. So initially the particle will accelerate and then retard it and comes to 0. So this is basically a question of work energy power. So you know that W net equal to what? Delta KE. So W net you may write E naught F into dx. So F is Q into E naught into 1 minus AX square into dx. And delta K initial velocity 0, final is also 0. So this will be 0. So just take a limit 0 to x. So Q into E naught x minus AX cube by 3 should be equal to 0. So that means you can easily get that okay, E naught you can take common, and E naught will be get into this side. So Q into x is this one. So x is equal to root over 3 by a from the above expression. So this is your solution. So the question given is the total charge enclosed in an incremental volume of something located at origin is something nanocoulomb if the electric flux density of its field is given, found as something. So you know that this is the differential form of Gauss law. Okay, so this operation is del by del x I cap, del by del y j cap, del by del z k cap. This is called the gradient operation, and E is E you need to find out. So from here you can easily write, if you multiply with volume, so you are getting what? E into V. So in the question given as electric flux density of the field, of its field is given to you, and you need to find out the Q. If you solve this one, this called gradient function. So this is this one, and you need to make a dot product del by del x. So dot of this one. So you need to differentiate this term with x, differentiate this term with y, and differentiate this term with z. You will be getting this one. So if you see the question is given at the origin. So just put x is equal to 0, y is equal to 0. So these two term will be 0. So this will be 2. And in the question given as electric flux density per unit volume, electric flux density means flux by volume. Flux is q by epsilon by volume. So q by v is how much? Rho. This is rho by epsilon. Rho by epsilon is how much? How much you are getting? You are getting rho by epsilon is equal to 2 from this formula. So this is 2. So this is your this is your rho by epsilon. So if you want to find out the total charge, so q should be equal to, just you need to multiply the volume with this. So the volume is 2 into 10 to the minus 9. So you will be getting 4 into 10 to the minus 9 or 4 nanocoulomb. So this is your answer. And one more thing, as in this question d is given to you, d is equal to E by epsilon naught actually. So whenever you will be, this is not your E, this is the D question given in the question, D equal to E by epsilon naught. So in place of E you may write, so you are getting this one is 2 by epsilon naught, these both cancel out, so Q is equal to this one. Next question. In the given question there is a dipole at the origin, so let it be the dipole at the origin. This direction is P equal to minus I minus 3J plus 2K into 10 to the power minus 29 coulomb meter. Now there is an electric field due to this dipole at some distance such that r dot p is 0. So r dot p is 0. So that means this is an equatorial point, and in the equatorial point the electric field used to be anti-parallel to the dipole vector. So if this is the direction of the dipole, so electric field will be opposite to it. So just put a minus before the dipole, you will be getting the direction of the electric field. So electric field direction will be I plus 3J minus 2K. So now moving on to the next question. This is a confusing question because the answer given by NTA I think the answer given by NTA was wrong in this question, because this is an asymmetrical figure. If you solve this one, so in this question what is given, there is a charge present at this point Q. You need to find out the flux through this shaded area. Okay, so if you need to find out the flux through this shaded area, so see, for this charge Q, flux through the adjacent face means this face and this face will be 0. So you will be getting flux for this upper face, this one, and this front face, this one. Okay. So total flux for any charge present at the corner is Q by 8 epsilon naught. So through this face, through each face will be Q by 24 epsilon naught. 1 by 3. There are 3 faces, and these 3 faces which are adjacent to the Q means this one, this one, and this one. For these 3 faces, the flux will be 0. So this is Q by 24 epsilon naught. Now, if you assume symmetry, then through this one and through this one, the flux would be Q by 48 epsilon naught. Q by 48 epsilon naught. Right? So, and for this one also Q by 48 epsilon naught. So through the shaded portion, the flux would be Q by 48 epsilon naught into 2, that is Q by 24 epsilon naught. This is the answer given by NTA, but this question is this answer is not correct, because this will only happen if this 2 portion is symmetrical with respect to this charge, then only you will be getting the answer. Students, I think most of the students have done this one, Q by 24 epsilon naught, but if you, I suggest you to see one of the video of Janardhan sir. He has well explained that why this is not correct, because this is not the plane of symmetry, right? So the actual question would have been asked like this. This would be the symmetrical surface. So if the question has been asked to find out the flux through this one, then the answer would have been Q by 24 epsilon naught. But in this case, NT has given this as the answer, and they have assumed that the flux through these two is symmetry. So that's why you are getting the answer Q by 24 epsilon naught. So in this case also, this one will not get Q by 48 epsilon, this one will not get Q by 48 epsilon, but this total this total portion will be getting q by 24 epsilon naught into by into 2, because there are two surfaces, so q by 12 epsilon naught. And this above portion, this one, there are four portion. So with this four portion, this vacant one and this vacant one, they are in symmetry, and this one are in symmetry, this one is in symmetry. So the flux will be equally divided into this shaded and unshaded portion. So this one will be how much? Q by 24 epsilon. So this would be the approach. मतलब ये दोनों मिला के Q/24 होगा. ऐसे नहीं कह सकते कि इसमें Q/48 होगा, इसमें Q/48 होगा. ठीक है. तो इसका अगर और सही एक्सप्लेनेशन चाहिए तो सर का एक बार वीडियो देख लेना. वहाँ पे सर ने ये भी बताया कि फ्लक्स मीन्स कोई भी ऑब्जेक्ट होगा, कोई भी ABC डिस्टेंस पे, उसके लिए फ्लक्स क्या होता है, उसका फार्मूला. पर ये तुम लोगों का लेवल का नहीं है, बस इतना ही याद करके रखो. So this is a good question from gravitation. A body is projected vertically upward from the surface of Earth with some velocity sufficient enough to carry to infinity. The time taken by it to reach the height h. So the body is traveling from this position to this position. You need to find out the time taken. First, you will find out the velocity. In this position, the velocity will be half mv e square minus gm by r, because it is already told that the velocity is sufficient enough to carry to infinity. So the velocity you may write VE. V is the escape velocity, and for this one the velocity will be half mv square minus gm by r plus h. So if you equate these two, you'll be getting the value of V is this one, and VE is root over t 2 gm by r. So you will be cancelling out this one. No need to write this all these things. So V equal to dx by dt, and this you may write r plus h or r plus x. Dx by dt equal to root over 2 gm by r plus x. Now from there onward, you will easily write dx r plus x dx. So you will be getting r plus x to the power 3 by 2. 3 by 2 is equal to root over 2 gm into t. So this is 0 to h. So you will be getting r plus h to the power 3 by 2 minus r to the power 3 by 2 by root 2 gm is equal to t. This. So here is a good question. India's Mongolian was sent to the Mars by launching it into transfer orbit EOM around the Sun. It leaves the Earth Earth orbit AE, something 1.5 into 10 to the 11 meter, and that of the Mars orbit 2.28 into 10 to the 11 meter. Then Kepler law give the estimates time for the Mongolian to reach Mars from the Earth. So this is Sun, and from here it is projected, right? And this is reaching in this orbit. This is the Mars orbit. This is Earth's orbit. So you may easily write this is an elliptical equation, right? In this question, what you should go with the approach. Let's assume this is the path followed by the satellite. So the area traversed by the satellite is this much. This one is pi v by 2. This is half of the ellipse. This is the full ellipse. So this is the area traversed by the satellite. This is pi v by 2. This one. So if you convert this one to a circle, if you convert this area to a circle, so you will be getting pi by 2 is equal to pi r square. Why I am doing so? Because you know that aerial velocity is constant. So area traversed by the satellite in time t, if this is pi ab by 2, let's assume this total area is equal to the area of a circle which is having radius pi r. So you may write r is equal to root over a into b by 2, and a is given to you. A is am plus ae by 2. This is a, and a is what? A is the major axis, and minor axis will be this one. So this will form an ellipse like this. This will form an ellipse. I am just drawing the figure. This will be the this shall be the equation. So this will be your minor axis, and this will be your major axis. So the major axis value is how much? A, and minor axis value is B. B means this total is 2B. 2B equal to 2R. So B should be equal to R. B should be equal to R. So from there, A you will be getting from this one AM plus A by 2 as 1.89 into 10 to the power 11, and B is already given to you. B is the earth radius 1.5 into 10 by 11 by 2. So whatever you will be getting from there, that will be R. And now you will be applying formula T square proportional to R cube, and for earth you know that T is 365 square proportional to A cube AE, that is the radius of the earth orbit. And if you do the ratios, you will be getting T equal to 260 days. So in this case, what is happening, I am just explaining once more. You are projecting the satellite is moving into this point. So in this case, the distance of the satellite from the sun changes, but in T square proportional to R cube, you are assuming that the path to be circular, but in this case the path is elliptical. So you need to convert this ellipse into some circle. So if this ellipse has area pi AB by 2, so let's assume there will be a circle whose area will be equal to this one, because the areal velocity is constant, that is pi r square. Then you are getting r, and just put the value of r, you will be getting the answer. You all might be having a confusion like why this is the minor axis. Let's see, the satellite is projected in this way. Let's assume the satellite is projected in this way. So it will be having two component of velocity, this one and this one. So this velocity will make the separation higher, and this will enforce the body to move in an orbit. So at this initial position, the distance between the focus of the ellipse and its periphery is minimum. So this position will be of the minimum distance between the ellipse and the focus. And you well know that the minimum distance between the ellipse and the focus is half of the semi-minor axis, or is equal to semi-minor axis, is half of the minor axis. So this should be your B. Whenever you will be moving from this point, the distance with the focus will changes. The distance with the focus will changes. Okay. So again, this is a question from electrostatic. Let a total charge 2q be distributed in a sphere of radius r, with the charge density given by something. R is the distance from the center. Two charges A and B are minus q each. These are two charges minus q each, are placed on diametrically opposite point at equal distance A from the center. So the distance between them will be 2A, because they are on diametrically opposite points. And if A and B do not experience any force, so this q and minus q may held at this position. So let's assume this is q, this is minus q, and distance between them is how much? A. So k q into q by a square will be the force on this minus q due to this q. Now this sphere will also produce a force. Okay, so this q is attracted by this minus q, so this sphere will repel this one, and this point may be inside the circle also, because if you take this is 2q charge, it is outside, so in case of outside the force will be constant, k into 2q by a square, the force will become constant. So the high probability is this q and minus q is within the sphere only. This is to diametrically opposite position. This is within the sphere. This should be minus q, this should be q. Now let's assume as this 2q charge is distributed over here, so if you find out field on this surface, how to do this one? So you know that E dot dA, q by epsilon naught, and E dot dA means E into area. Area is, let's assume, 4 pi r square equal to q, you may write rho into dV by epsilon naught. What is rho? Rho given to you is kr. So kr into dV is 4 pi r square dr by epsilon naught. If rho would have been constant, then you may clearly write over by 3 epsilon, but rho is changing, so you need to do the integration. So E into 4 pi r square. Now you'll be getting 4 pi k r square, r means r cube dr, r cube dr, r cube dr means r to the power 4 by 4 into 4 pi r square. So this 4 pi cancel out, r square means this is r square. So E equal to kr square by 4 epsilon naught. Now the thing is, you need to find out k also. You need to find out this k also. So you need to find out this k also. This makes the question a little difficult. So for this k in the question, it is clearly given that r is the radius of the sphere and 2q is the total charge. So you may clearly write total charge 2q would be equal to rho into dv. So rho is how much? Rho is kr, dv is 4 pi r square dr. So you may clearly write 4 pi k r cube dr means r to the power 4 by 4. And if you put the limit 0 to r, this will be r to the power 4. This will be 2q. From there you will be getting k equal to q by 2k pi, sorry, 2 pi r to the power 4. So this will be this one, 2k by pi r to the power 4. So you will be writing this one. So as this had been said that these two are diametrically opposite points, so this will be this point only on the surface, because the answer is given in this form. The point may be inside the circle also, but the answer is given in answer. There is no form of r, so this will be the point on the diameter. So if you put this limit of this r, you may write 0 to capital R. So this one will be r square, and this will also be r square. So, and this force is applied by the sphere on the charges 2q. This is the electric field. Force will be again 1q will be multiplied with this, and this is the force by the charge on another charge. So if you equate this one, because the net force is 0, this pi epsilon get cancel out, and all other r square sorry, as this has been said that these are diametrical opposite points, so you will be applying 0 to A, not R, 0 to A. So this will be A. So this total is coming A to the power 4 equal to 8, R to the power 4. R to the power 4 by 8. I made a mistake here. This is the 1 by 4, so this will be 2. So this is R to the power 4 by 8. So A will be 8 minus 1 by 4 to the power. The calculation is a bit hectic, but this is a solution. So there are two equal positive charge Q and Q placed at 2a distance apart. In the next question, sorry, and given as there is a test charge in it. Let this test charge is Q naught. So you need to find out the force explained by Q naught, which is become maximum at A by root x. So this Q will give it a force along this way. This will give it a force along this way. So let's assume this is theta. Let's assume this is theta. So this is Q naught. So this force will be K into Q naught. This is 2a, means this is A, this is x. So A square plus x square root by square, because this is A square plus x square. Now as this force is F, so there will be two component of the force along this one, along this one. As this is theta, so this one will be also theta. So I can clearly see that this cancel out. So the component of force along this direction, that will be cos theta. So that will be present 2f cos theta. So the resultant force will be 2k q into q naught a square plus r square. This square and root get cancel out, and or you can keep it as it is, because I will be needing this one later on. And cos theta, so cos theta will be how much? Cos theta is x by a square plus this is x square
3 by 2.
So you are getting the expression as 2k q into q naught x a square plus x square to the power 3 by 2. So this is the similar expression that you got in case of a ring. And you well know that for a ring, the maximum electric field occurs as x is equal to plus minus a by root 2. So here also you will be getting the same thing. Otherwise you need to differentiate this one, d by dx x by a square plus x square to the power 3 by 2. Whenever you will be differentiating this one, you will be getting x is equal to a by root 2. That will be the point. So x equal to a by root 2, it will be maximum. The electric field value will be maximum. If this test charge would have been a negative charge and told in the question that a is very greater than x, then you may cancel x square. Then your electric field term would come 2k q into q naught by a cube into x, and not electric field, that will be the term of force. So this will be the term of force. So F is equal to m into a is equal to this much. A is acceleration. So you are clearly seeing that a proportional to x. So in that case, it might have been asked to you to find out the omega. So omega will be how much? This one. This one will be your omega, and the time period you can get from there. And this is the case of a stable equilibrium, because as it is doing SHM. But if this charge is plus q naught, then this point is an unstable equilibrium point, because whenever you are moving this plus q naught to this side, then the resultant force is insisting this q naught charge to move to this side only. This will not come back. But if this charge is if this charge is negative, then in this case it will be having a stable equilibrium. If this charge is positive, then it will be a case of unstable equilibrium. In this question there are two charges, plus q and minus q, and there is a this is the sphere. So you need to find out whether the charge inside the sphere and the charge density inside the sphere and outside the sphere is 0 or not. So this is sigma 1, this is q1, this is sigma 2, this is q2. So if this is q and this is minus q, so the amount of charge induced inside will be equal and opposite. So for this plus q, a charge will induce in this portion, in the above portion, this one, a charge will induce for this plus q. That will be opposite in nature, so that will be minus q. And in this portion, the induced charge will be plus q. So the net charge will be 0. Net charge inside it will be 0. But as there will be some charge in this and some charge in this portion, so there will be charge density. So sigma 1 will be present, but q1 will be 0 because of equal and opposite charge. But in this case, if you observe that uh, this is sigma to q2, as inside total charge is 0, so there will be no charge in outside. So as there will be no charge in outside, q2 is 0. As there will be no charge in outside, so there is no chance of induction. So q2 is 0 means sigma 2 is also 0. So option C will be your answer. So this is an easy question. Correct formula for height of the satellite from Earth's surface. You well know that t square proportional to r cube, and t square is equal to 4 pi square by gm into r cube. So you can easily find out gm is equal to g into r square. So from there you can easily find out this r is g into r square t square by 4 pi square to the power 1 by 3, and this r is r plus h. So you can find out h is equal to this much. So this is an easy question. Now this one, in binary mass system, this is a case of binary mass system. So I'll first explain binary mass system. There will be two mass, m1 and m2. As there is no external force, so f will be 0, so delta r cum will be 0. Because there is no forces, so center of mass will be remain in its initial position. So this mass is moving in this orbit, this one is moving in this orbit. So r1 plus r2 is equal to total distance between them, that is d. And you can easily write m1 r1 equal to m2 r2, because delta r cum is 0. From there you will be getting r1 and r2. So if you equate force with centrifugal force, gmm by d square, because this one will apply force on this, so gm by d square along this one, as this is moving with velocity v1, so mv square by r will be along this one. So v is omega square r, m omega square r is this one. So omega will be root over g m1 plus m2 by d cube. So omega is constant irrespective of the masses, because for this mass also omega root over g m1 plus m2 by d cube, for this mass also root over g m1 m2 by d cube. So omega 1 equal to omega 2 independent of f. This will be your correct answer. Just read the question once. This is your solution. In this question, re be the radius of the earth, then the ratio between the acceleration due to gravity at depth r and height r above the earth's surface. So for depth, depth will be g into 1 minus r by r. For height, g into r square by r plus r square. You may write this one like this. So just make the ratios. You will be getting 1 minus r by r, 1 plus r by r whole square. So if you solve this one, 1 minus r by r plus 2r by r minus 2r square by r square plus r square by r square minus r cube by r cube. So you are easily getting 1 plus r by r minus r square by r square minus r cube by r cube. Option 1 is your correct answer.